right, hope you enjoyed the Irish introduction. That's a little bit more of my Irish jig I composed. All right, so let's see what we will be doing today. We're going to finish up this section with the chain rule, but we're going to be looking at repeated use of the chain rule. One thing I like to do a lot with chain rule is I like to relate it to a Russian doll. So it's kind of like this. If you know, this is not going to be a very good Russian doll, but okay, here's your Russian doll. If you open it up, there's another smaller Russian doll. So you can think of this as the big function. You can think of what's inside of it as another function. And then if you opened up g of x, you would get an even smaller function, which would be maybe h of x. And theoretically, you could just keep going on like that. So chain rule kind of reminds me of a Russian doll. You do the derivative of the big part. You do the derivative of the big. Then you multiply by the derivative of the next part, which would be, kind of the inside part here. And then you multiply by the part that's inside of that. So it's kind of like you just keep going multiplying each level like that. So this can be a little confusing when you look at this, but this would be like three functions. You have h of x inside of g of x inside of f of x. So what you start with is you start by doing the derivative of the big function. That would be the f of x. So you're doing f prime, and this just stays the same. Then you go to the next level, so you're kind of going to the inner level of that. And then finally you go to the innermost level like that. Okay, so think of the chain rule like that, and I think that'll help some. Okay, so let's look at several examples of this then. And again, we know if we're working with radicals, what we're used to doing is just changing this to a 1/2 power. So let's go ahead and write this like this. We'll have brackets. We'll have 3x minus 2 to the second plus 2x all to the 1/2 power. And what you have in here is you have a function there. That would be the function inside of the function to the 1/2 power. But then inside of that, you've got maybe another function here that you're going to have to do another level of the chain rule on. So you can kind of think of it that way. So let's go through and let me show you how you do this with the chain rule. So dy over dx, okay, we do bring the half down. Leave what's inside totally alone. Don't touch it, just write it down. We know that we subtract 1 from the exponent, so 1/2 minus 1 gives us negative 1/2. Okay, then you pause, and then you have to do the derivative of the inside part. Now that's what I have in yellow, so we need to do the derivative of 3x minus 2 to the second plus 2x like that. Okay, so we kind of do this in a few steps, so we start like that. So what we'll do is we'll bring down this first part. This is the big function right here. We did the derivative of the big function, and we're just going to leave that alone, so bring that down. Okay, that's to the negative 1/2 power. We're just going to leave our exponents as negative. That's okay. Now if we do this derivative, the inside part, well, you could multiply this out, but I'm going to demonstrate the chain rule. So when I do this, this is a chain rule right here, see? So I bring that 2 down. That would be 3x minus 2 to the first power, and then I have to multiply by the derivative of what's inside there. So see, that's kind of like the innermost function there. And then I got to do the derivative also of 2x, and the derivative of 2x is plus 2, like that. Okay, so just kind of pay attention to what I did. There's the derivative of big, derivative of what's inside. Had a chain rule right here with the 3x minus 2. So I got to do that to finish this up then. All right, so we'll bring this down. We have 1/2 times 3x minus 2 to the second power plus 2x to the negative 1/2 power. And then from here, we could go ahead and multiply this out, or we could leave it in a factor form. I'm going to multiply that out to get 6x minus 4. Then the derivative of 3x minus 2 is going to be 3. and then bring down the 2. So at this phase right here, we have completed the derivative of that function. All right, so now we would just bring this down, keep doing that, don't forget about it. And then we'll just kind of do the algebra, collect some like terms, and then we'll be done with it. So this would be 18x minus 12 plus 2, and then you can put these like terms together here, and we'll just write the answer as 1/2 times 3x minus 2 to the second plus 2x, the negative 1/2 times, that would be what, 18x minus 10. And that's good enough. Now, what you could do, I think it's probably worth doing one more step on the problem. When I see this half, I mean, you could go through and distribute this half like this. If you want to just take half of those numbers, you could do this in your head. So I think a good way to write this answer would just be 3x minus 2 to the second plus 2x. Now, if you're taking half of these, that's going to give 9x minus 5. Okay, so that would be a good answer to that problem. Okay, so if you kind of go look back at what I did, I'm really applying this chain rule with 3 levels. The big function, we bring the half down, subtract 1 from the exponent. That's the big part. Then work on the derivative of the inside part. So it's going to get simpler as you go. I just kept bringing this part down, and then notice what I did here. This is chain rule right here. Bring the 2 down, 3x minus 2 to the first, multiply by derivative of what's inside, and do the derivative of 2x. Okay, so that's how that goes, and then the rest of that is some algebraic simplification. Okay, I'll move to the next thing, and these again are just looking at multiple levels of the chain rule. Okay, so let's take a look at this one. Now, what happens on this one, the big function is you're just doing the derivative of the sine of something. So we're going to start by just focusing on, the big Russian doll. That's the derivative of the sine, which we know is the cosine of something. And then we have a function inside, which is a cosine, but then we have another function inside, which is x to the 4th. So you got 3 levels here. So when we work this out, do dy over dx, this one's going to work out like this. Okay, the derivative of the sine is the cosine of whatever. Okay, and I don't touch that inner part right now. That's part of the answer to your problem right there. Okay, now what you have to do is you have to focus on the derivative of the inside part. So we're going to focus on the derivative of cosine of x to the 4th, which is again another chain rule. We know the derivative of a cosine is a negative sine of something, but then we have to multiply by what's inside, the derivative of what's inside. So you can think of 3 Russian dolls, the big, the inner, and then the next level, like that. Okay, so I'll just kind of keep bringing this down. I'm still going to have cosine of x to the 4th. Okay, now when I do this derivative, we know the rule for the derivative of a cosine is negative sine of whatever. Okay, pause, take a deep breath. Now do the derivative of the innermost function, which is the x to the 4th power, like that. Okay, then we'll just put this together and see what we got. So we keep bringing this down. And when you're writing your steps, keep bringing stuff down, because if you don't, you're going to forget about it. And let's see, I'll write this as negative sine x to the 4th. And then finally, this derivative here is going to be 4x to the 3rd. And all we need to do is just write this. And what I would always recommend doing is, if you have trig functions, it's always a good idea to put stuff in front. So let's write the final answer like negative 4x to the 3rd. Doesn't matter which trig function comes first, so I'm going to write that as cosine of x to the 4th, and then sine of x to the 4th, like that. Okay, kind of fun, isn't it? Heck yeah. All right, so that would be the idea. I always like that Russian doll thing because it always sticks in my head. It's just you have 3 levels of functions on this problem. Sine, cosine, and x to the 4th are your 3 levels of functions, nested inside of each other. Okay, next one. Now, again, we have a square root. You have a big square root and a square root under it. So the way to write this would be like this. To start with, just write this as t plus square root of t to the 1/2. And you're going to have to change this other square root to a 1/2 anyway, so you might as well just do that at the beginning. So before we do the derivative, let's write it like this. T plus t to the 1/2 all to the 1/2 power. Okay, so you do have really 3 levels of chain rule on this. The big function is just the whole thing to the 1/2. So think of this as a power rule. So you're going to bring the half down, subtract 1 from the exponent, then multiply by the derivative of what's inside. So that's the part that's inside of the bigger function. Okay, so when we do this, we'll have dy over dx. This is going to be 1/2 t plus t to the 1/2. Subtract 1 from the exponent, which you can do in your head. I just kind of keep writing down what I'm doing. So we got that. And then we're going to multiply by the derivative of what's inside. Okay, so I'll kind of get this going, try to maybe highlight the different levels as I'm doing that. All right, so that's how the chain rule would start on the problem. And again, we're just going to keep bringing this part down. So this will be 1/2 t plus t to the 1/2 to the negative 1/2 power. And now we're ready to do this derivative. So the derivative of t is the number in front, which is 1. We got to do a power rule on this. So this would be 1/2 t to the negative 1/2 like that. So actually this doesn't really have an extra level in it. Okay, at this stage right here, you've done the chain rule. And at this stage, I think probably not much that I'm going to want to do on this problem. You could change everything back to a radical. That's probably a wise thing to do. So I'm going to write this as 1/2 t plus the square root of t all to the negative 1/2 power. And then inside the parentheses, I'll write this as 1 plus 1 over 2 root t, like that. And you could leave the answer that way. You could also bring this negative exponent down the bottom. It's kind of good to just work with some algebra on these. So I'm going to bring the half down. This is going to be 1 over the square root of t plus the square root of t, like that. And then this part right here, which you would have to have in a grouping symbol, would be 1 plus 1 over 2 root t. Okay, so that's probably okay to just write the answer like that because you've got distinct factors broken up like that. Okay, all right. So that kind of gives you a little bit of an idea of how to do a chain rule when there's more than one level. Okay, I'll move to the next page, and I'm going to do some of these that have combined rules to it. And again, when you're doing the chain rule, excuse me, doing the chain rule, think of what the big function is. Okay, think the big Russian doll is something to the 5th power. So you're going to do the derivative rule for a power rule, really. You're going to bring the 5 down, subtract 1 from the exponent, but then you're going to multiply by the derivative of what's inside. So the function inside is 2x over x plus 1, which has to be differentiated with a quotient rule. Okay, so it goes like this then. We'll have dy over dx. Okay, start the big rule. We're going to have 5 times 2x over 2x plus 1 to the 4th power. Okay, pause, take a deep breath. Now do the derivative of the part that's inside, which will require a quotient rule. Okay, so that's how you start that off, is like that. Okay, so again, keep bringing stuff down. Now we're going to try to simplify this thing as far as we can too. I'm not really sure why I put that 2x plus 1 there, so let me fix that. So we got that. As we're going through this, let's just keep bringing this down for now, and I'll show you at the end how we're going to need to simplify this. Okay, now we have a quotient rule. So remember, your quotient rule is bottom times derivative of top minus top times derivative of bottom over bottom to the 2nd. So we're going to put that part in the quotient rule. Okay, so we got the bottom, x plus 1, Now I can kind of just do this in my head. The derivative of the top is 2, so you can do that in your head. Then minus the top, which is 2x, times the derivative of x plus 1, which is just 1. So you can do that part in your head, and then let's write the bottom squared like that. So at this stage right here, we have done the calculus. We have a derivative right here. We're already done with the derivative. But we do need to simplify this as far as we can. So what I'm going to do here, I'll bring the 5 down. And anytime you have a fraction to a power, you can just think of this as the numerator to that power and the denominator to that power. Just write it like that. Then we'll begin to simplify this. So this has some distributive property stuff in it. So that's 2x plus 2 minus 2x all over x plus 1 to the second power, like that. Notice we do have a cancellation there. So let's write what we're left with and see how far we can take this. So we've got 5 times. Now you can multiply this out now. So if you have 2x to the 4th, you're really just doing 2 to the 4th times x to the 4th, which is 16x to the 4th. You can also look at this just as a 4th power means you're multiplying something out 4 times. So you'll get 16x to the 4th if you do that. So you do want to go ahead and multiply that out. And then we'll just leave the x plus 1 to the 4th alone. And then what we're left with here is 2 over x plus 1 to the second. Right? So the only other thing I can really do on this, you can just multiply this all straight across. These are 3 fractions multiplied straight across. So you've got 5 times 2 is 10. 10 times 16 would be 160 x to the 4th. And then notice that these things right here are really like terms, so you just add the exponents on that. So this would be x plus 1 to the 6th power, and then that would be a great simplified answer right there then. Okay, so that's a good example of one where you're doing combined rules. You have a chain rule and you have a quotient rule within the same problem. Okay, so we'll move to the next example here. I want to do a few more, then I'll have you do some problems. So this is another one. This one has 2 things being multiplied. So you see on here that we have 2 functions. So this would be a product rule. And when you're doing the product rule, the way that I go over this is it's the first times derivative of second plus second times derivative of first. You can do that backwards also. So a lot of times students go derivative of first times second plus first times derivative of second. You know, it's up to you which order you do that in. Doesn't matter. Okay, so I'm going to call this one the first one and then this one the second one. Okay, so when I set this up in my product rule, this will be dy over d theta. So we write the first, then we're going to multiply by the derivative with respect to theta of secant 4 theta, plus, now I'm going to do it backwards, I write down the second, and then I'm going to multiply by the derivative of the first. Okay, so we got to do these 2 derivatives. One of them has a chain rule on it as we do that then. Okay, so this is the chain rule. The big rule for a secant, the derivative of a secant is a secant tangent. But you also have this 4 theta you got to deal with, so you're going to do a chain rule. So I'll bring down the theta. Now, this would be the derivative rule for secant is secant tangent. And see, I'm putting that 4 theta as the argument on that. But since 4 theta is a function, beyond just having theta, if it just had theta, you wouldn't have to think about the chain rule. But we have to multiply by dd theta of 4 theta. Okay, now the second part we just bring down, we'll have secant of 4 theta, and then derivative of theta is 1. You know, that's like doing the derivative of 1x with respect to x. That's the number in front. So that means what we have to do this derivative, and then after that, we'll just see if there's any simplification that we can do. So this will be theta secant 4 theta tangent 4 theta times 4, and then over here this will be secant 4 theta. Okay, so when I look at a problem like this, I do see factoring. Anytime you can factor something, you definitely want to factor. So this is a common factor that can come out. There's one big term and another term. So we can take that out. So I'm going to remove the secant 4 theta. And when I take that out, you can kind of block this off in your mind. We have a 4 theta, tangent of 4 theta. Again, write stuff in front of your trig functions, and then this would just be a 1. When you take that out, you'd have a 1 left over. So that would be a good factored answer to that problem then. Okay, so that's product rule that has a chain rule inside of it. Okay, now I'll move to the next page, and I want to look at one more illustration. This is a good problem right here that's got some good algebra involved in it. So you have to know where to start on these problems. You got to see what do you have, what's the situation going on in this problem. When I look at this problem, I see two functions multiplied. You know, I see a first function multiplied by a second function. So again, this is a product rule. You can't start with the chain rule here. You got the big entire function requires a product rule. You always look at the big all-encompassing function. So we have first times derivative of second, second times derivative of first. So let's go ahead and get this put in the product rule. Okay, so we're going to write down the first. We're going to multiply by the derivative of the second. I'm just going to set it up in the product rule. And then plus, and then do it backwards. Write down the second. And then multiply by the derivative of the first. Okay, so that's just going directly to the product rule. Doing what the product rule tells you to do. Now our focus has to be on these two derivatives right here. Okay, so just keep bringing stuff down. Don't forget about this step. That's x plus 2. Now this part right here, see, is a chain rule. Okay, the big function here is something to a third power. So you bring that down, subtract 1 from the exponent, but you have to multiply by this function, the derivative of this function inside. So that's 3 times x squared plus 2x to the second. Now you can do this in your head. So if I do this derivative part right here, this inside part, okay, that's going to give me 2x plus 2. All right, now we go to the next part of the problem. Just bring down the x squared plus 2x to the third. And then the derivative of x plus 2 is just 1. Okay, so we have that. So at this stage right here, we've completed the calculus. Now, what we need to do on this is when you have a problem like this, you want to think about factoring. You know, that's kind of the big deal is there anything that we can go through and factor out of this? So that's what we're going to take a look at. Okay, so I'm going to just sort of clean this up a little bit. I mean, you don't really have to, but I'm going to take this 3, write the constant down in front of all this stuff, and then this would be an x plus 2. You could take a 2 out of this. You should probably take a 2 out of that, so we'd have 2 times x plus 1, and then I'll just leave this alone, x squared plus 2x to the second. Yeah, you could take an x out of that. I mean, if you had x squared plus 2x to the second, you could write it like x times x plus 2 to the second power like that. And we may have to do that at some point later in the problem as well. Okay, and let's go ahead. Now let's move to this next part, which is x squared plus 2x to the third power like that. Okay, now what I notice on this, when I was doing this at the side of the paper, see how we had that extra factor in there? So I think it's probably worthwhile to do this before we factor stuff out. Okay, so I'm going to go ahead and change this now. So this is going to be 3 times, let's put together what we can. Okay, so I see that I have a 3 times 2, I have a 6. So let's certainly write that as 6. X plus 2 x plus 1. And see this part right here that I was doing over here, you look at this little part right here, it can be written like this, but then you can split this up into x squared times x plus 2 to the second. Okay, so that can be written that way then. Okay. All right, so let's write that then. We'll write this as times x squared times x plus 2 to the second power. Okay, and then when I move over here, I'll be able to handle this kind of in a similar way then. Okay, now let's move over here and let's work on, this part right here. Okay, so same idea. You have x squared plus 2x to the third power. You can factor out an x inside, and then you can raise both parts to the third power, so you would get x to the third times x plus 2 to the third like that. Okay, so this will be x to the third, x plus 2 to the third like that. Okay, so now we've done all this factoring, but there's more we can do. When you look at this problem, you can think of this kind of like this. I like to, when I teach this, kind of box stuff in. So this is a part right there. And let's see, there's another part right here. Kind of fancy that I can do that. There we go. That's cool. Okay, so what we do is we look inside these boxes and we think, okay, what's the common factor that comes out? Well, remember you learned to take out the expression with the lowest exponent. So when I look at this, so I've kind of got this x squared and I have that x to the third. So the one that comes out is x to the second. We're going to take that out when we do that. Okay, we also have this x plus 2. Hold on, what did I just do? Okay, here we go. So we got this x plus 2 to the second and x plus 2 to the third. So the lower exponent is x plus 2 to the second power like that. Okay, now that's all I see that's the same in these brackets or the boxes. So I'm going to do this. I'm taking that as a common factor out then. Okay, now if this helps you, sometimes this helps students a lot to do it this way. This is our common factor. So if I just divide this entire thing in this box by x squared, x plus 2 to the second, look what happens. The x squareds cross out, the x plus 2 to the seconds cross out, so you're left with this thing right here. Okay, so that's going to be 6 times x plus 2 times x plus 1, which, yeah, we'll have to multiply that out. So we have that. And then over here, we would have to divide this by that common factor, which is x squared, x plus 2 to the second. Okay, like that. I actually see an extra thing on here. I didn't spot this other x plus 2 there. So there's probably a better approach that I could have done. I did not spot that, so sorry about this. I'm going to erase this. I mean, we could probably continue that way and get to where we needed to go, but I just didn't spot something on this. So let's go ahead and let's do this. One more step. Okay, I'm going to bring this down before I factor. I have 6. I've got a x squared. I'm going to write that in. I've got an x plus 1. And then I've got x plus 2 to the first, x plus 2 to the third. So that's going to be x plus 2 to the third power. Okay, then all this stuff over here just comes straight down. Okay, so that'll make the factoring kind of turn out kind of nice then. Okay, so now I'm going to do that kind of that same approach. I'm going to draw a box around these two parts. I think this is a nice little visual tip when you're doing this on a problem like this, because it's got some pretty advanced factoring in it. So we got this. Now we just look inside. What are the common factors? Well, again, we can take out an x squared. We can take out the lowest exponent. That's going to come out. But we also have this x plus 2 to the third, which is a direct match. So we take that out. So we have x plus 2 to the third. And then we're going to draw our bracket, and then we're ready to fill in the blank. Now, you can fill this out in your head. A lot of students struggle with this, so I'll show you what you want to do. If you struggle doing this in your head, then what I would suggest that you do is just take each big term and divide it by this common factor that you see. Okay, so divide this by x squared, x plus 2 to the third. That will wipe that out. That will wipe that out. And then write what you're left with. So you're left with, you can see, a 6 times x plus 1. Like that. Okay, now let's go over here and let's do the same thing here. Divide this by the common factor that you took out. Okay, that'll wipe that out, and that will wipe one of those out, leaving an x. So you're just going to be left with an x like that. Okay, now we just got to simplify what's inside, and then we've got a beautiful factored answer on this problem. So we have x squared, x plus 2 to the third. Okay, now I'm just going to kind of do this at the side. This would be 6x plus 6 plus x if you do a distributive property. And then you could get the like terms together to get 7x plus 6. Wow, that's got some great algebra in it. And this is a problem that really, if you can handle factoring at this level, you're a master of factoring if you can do that well. So that's something that students need to work on. A problem like this, the factoring aspect shows up later in the class. All right, pause and look at that and study that if you need to. Okay, student says, do we have to factor? Yeah, you have to factor. You need to get that one all the way down to the bitter end. Okay, all right, go ahead and we're going to do a couple of problems to wrap up this section. So I want you to do number 1 on the bottom of the page, and then number 2. Then I will go over one more example too. So you can go ahead, pause the video, and please work these out before you look at the video. See how well you can do these, and then we'll do that last example. Go ahead and pause. Resume when you're ready. Okay, so if you can do these problems, then you're doing well, I think, with your algebra, particularly that number 2 with the factoring that shows up. So number 1, the answer I would be looking for, this is as simple as you're going to get this, is 24t to the 4th times t minus 2 over t minus 1 to the 4th. All right, I'll go ahead and kind of talk through this. So, you're starting with it's a chain rule, so, but the big function is to the 3rd power, so bring the 3 down, subtract 1 from the exponent, leave what's inside alone, but then by chain rule, multiply by the derivative of what's inside, and that is a quotient rule. And the quotient rule, again, is bottom times derivative of top minus top times derivative of bottom over bottom squared. So I did this bottom, t minus 1, derivative of top is 4t, minus the top, 2t squared, derivative of bottom is 1, over the bottom squared. So this right here is a quotient rule. And I'm just kind of bringing things down. Distribute, that's 4t squared minus 4t. This is minus 2t squared. The way you handle this is, square the numerator, square the denominator. So if you do this, okay, this will be 2 to the second is 4. T to the second is t to the 4th, because you multiply the exponents. And then you just bring down the t minus 1 to the second. Like terms, you can put together there to get a 2t squared minus 4t, like that. And then I decided, well, let's factor a 2t out of this part. So I take that out, and I've got 2t times t minus 2. You can kind of distribute to check that that's right. And then from here, all you got left over is 24. I did make a little mistake on that, though. I'm just glad I caught that. So that would be t to the 5th. Right there, because you've got t to the 4th times t, so we'd have that, times t minus 2 over t minus 1 to the 4th. Okay, so pause if you need to look over that if you didn't get that. Ideas chain rule, and then you've got a quotient rule inside, and then a lot of algebraic simplification. Okay, next page. The answer I would be looking for down at the bottom, 2x minus 5, x plus 1 to the 2nd times 10x minus 1. Okay, the big function is a product rule. You have 2 things being multiplied. You've got the first there, and you've got the second there. So I start by just putting this directly in the product rule. I have the first times derivative of second plus the second times derivative of first. Just get it in the product rule. Then we do the derivative right here. So we're doing this derivative. When this comes down, that is a chain rule. So bring the 3 down, x plus 1 to the second, times the derivative of what's inside. Okay, over this part, bring the x plus 1 to the third down, and then you're doing a chain rule here. So that's 2 times 2x minus 1 to the first, times the derivative of what's inside. And you can do the derivative of what's inside in your head. So what you'd have in the next step, I decided I'd just bring the 3 down. I got 2x minus 5 to the second, x plus 1 to the second, derivative of x plus 1. That part right there, derivative of what's inside is 1. Go over to the next part. I got the 2 there, times 2 is 4, x plus 1 to the third, 2x minus 5. Now, when you get down to this point, see, you've done the derivative. You're done with the calculus. The rest of this is factoring. So I drew a box around these to figure out the common factor. Look what's the same. 2x minus 5 is the same. So you work with the lowest exponent. That's a second power. That's a first power. That comes out. X plus 1 is a factor. Work with the lowest exponent. Okay? Now, if it's hard for you to figure out what goes in this bracket, just go over on scratch paper and do this. See, I wrote down what I'm trying to factor, and I divided by this common factor we pulled out. That's why I've got that 2x minus 5x plus 1 to the second. If you do it this way, it keeps you from having to do this in your head, and it'll make it pretty simple, I think, that the x plus 1s cancel out. 2x minus 5 to the second over 2x minus 5 to the first leaves you 1 left over. And then over here, notice the 2x minus 5s divide out. X plus 1 to the third over x plus 1 to the second leaves you with 1. So see what you're left with is you're left with this. That goes there. And then from there, it's easy to finish up. It's just a matter of distributive property, 6x minus 15, 4x plus 4, collect like terms, and then you got it. Okay? All right, so I hope we did okay on those, or you got close. I mean, the first time you do those problems, it can be a little challenging. You saw, like on the first one, I made a little mistake myself. So pause if you need to look at that. Otherwise, we'll go to the last problem to finish up this section. And this is just sort of an exercise to see how well you understand the chain rule in a more abstract situation. So what we have on this table here is these are x values. This is what f of x is. This is the derivative of x. And then this is the function g of x and its function values. And this is the values of the derivative. So I'm going to do one problem and then let you try this part B, which is essentially about the same thing anyway. So what we have is we're going to do h prime of 3. And what this says is, by definition, g of x is a composition of functions. So we're going to replace that with f of g of 3 like that. Okay? Now, we're not really ready to do the derivative yet, so I should take that off and write this like this. So I've got h of 3 by definition, and the problem is the same as this. Now, when I do this derivative, this is a chain rule. The big function is f. So you focus on doing the derivative of the big function. So that's f prime g of 3, like you've been doing. It's just the derivative, leave the part inside alone. Now, the chain rule instructs you to do the derivative of what's inside, which would be g prime of 3. So what we're ready to do now is we're ready to look at our table and identify some things. So let's find g of 3. Here's 3. G of 3 is 1. So just keep bringing this down. We still have f prime, but g of 3 is 1. Then we need to identify what g prime of 3 is. So g prime of 3 is 20. Okay, so now we've got that. Okay, now we're not done yet. We got one more thing to do. We need to look up what is f prime of 1. So here's 1. F prime of 1 is 5. So it looks like what I end up with is 5 times 20. So the answer to that is 100. Okay, so that's just kind of doing the chain rule in an abstract situation. It's a great way to test students' understanding of the language and the symbolism of the chain rule. Okay, so I would like you all to do part B, and go ahead and pause the video, and I'll let you work on H' 2. It's not much different. It's pretty much the same idea. See what you get on that, and then that'll wrap us up. Okay, so the answer I hope you got was -100. It's very similar to the last problem. Only difference is you have evaluating at different numbers. So you want to write your function as f of g of 2. Chain rule would be f prime of g of 2 multiplied by the derivative of what's inside. Look up g prime of 2. Here's 2. G prime of 2 is 10. Look up g of 2. That's what I got in blue. That's 5. So now I bring that down. I've got f prime of 5 times 10. Here's 5. F prime of 5 is -10. So that's how I get the answer. Okay, the end. That will wrap us up. Hope you enjoyed the video and hope you do well with your work on the chain rule, which is an incredibly important big derivative rule that you'll use constantly. All right, good luck. Cheers.